Hello, this is Chuck Ridgway, Automation Technology Manager at Horner. Thanks for joining us for another Tuesday live stream. Well, we're in the second part of what ultimately will be a three-part series on structured text. Here's our topic for today: find operations using structured text. Now, last week, we covered string operations in structured text in the standard IEC package in Cscape. Today, it's all about find operations. Now, when is it useful to find a specific value in a list of values? That's what we're talking about today. What applications is that useful, and how would you go about that using structured text? Now, I am pre-recording today because I'm on vacation, but rest assured, we have folks standing by to answer your questions. If you were watching live, just give us those questions in the chat section. If you're watching on replay like a lot of you do, don't hesitate to give us your comments and questions in the comment section, and we'll get back to you just as soon as we can. All right, let's go ahead and dive right in and take a look at how we're breaking down today's topic. Okay, we're going to start out by going through those applications where finding a value in a list of data is useful. So we're going to talk about a couple of those. And we're going to introduce some data-find, user-defined function blocks that you can use in your program that's going to make this easier. And we're going to show you how to use those in structured text. And there'll be plenty of demonstrations throughout. So without further ado, let's just get right down to it. Okay, so let's talk about a couple of example applications where it would be useful to search through a list for a specific value and get an index back for where in the list that value has been found. All right, so here's an example for you. So let's say we have an array of part numbers. Maybe we've got a machine that's managing tools in a machining center or something like that. And for every tool that we're storing and retrieving, there's a number of parameters to it. You know, maybe not only a part number, of course, for that tool, but maybe length, width, height, weight, whatever the case may be, a variety of different parameters. And each of those parameters might be located in a separate array of data, but those arrays are all correlated in that they have the same indexes. So for a given part number that you find as the fifth element on the list with an index of 5, that same index of 5 through the list of lengths, widths, heights, and weights is where you can find the parameters for, you know, that particular tool correlating to that particular part number. So searching through a list for a specific part number, because that's the tool we're going to run next, would allow us to retrieve similar information from different arrays for the same part. So that's just an example where we might want to search through a list of data values and come back with an index of where in the array that particular data value was found. And to help you do that and to kind of illustrate what I just talked about, here is, I guess, a view of a user-defined function block in ladder in this case, where we are performing a data find operation. We're looking for a specific integer value that represents a part number from an array of data. And then once we find that index where that is found in that array, which in this example on the screen is an index of 36, then we know that we can retrieve using that same index the length, width, height, and weight of that particular part number from other arrays that are correlated to it. So that's just an example of one case when you might want to search through a list of data to find a specific value. Now, another example actually is very similar to what we talked about last week. Last week, we talked about string handling, and we introduced several string functions to you, not only some built-in string functions, but also, again, some user-defined function blocks that have to do with strings. And one of them that we talked about last week as well, we're going to talk about it this week too, and that is a find character UDFB. Well, this one is useful in an application where, let's say you're reading in barcode data, and you've got a string of characters, and you need to find a specific character in that string that maybe points at a data field that you want to parse from that barcode, for instance. So again, another case where you're going to be searching through a list of data. This time, it's a list of characters, okay? And you're going to search for a specific character. Well, a character is just a data value, really. So that's another case where looking through a list of data for a specific value can be pretty useful. Now let's talk about some user-defined function blocks that we're going to review with you today that are going to allow you to perform these type of data find operations in your applications. Now, they're listed there in that yellow box on the screen, And the first 4 of them listed top to bottom are effectively the same, but they only really vary in terms of the type of data that you're searching through, the type of data in the array you're searching through. Is it a short integer or a byte? That's the top one there that ends in SI. Is it an integer? Is it a double integer? Is it a real value? So those first 4 user-defined function blocks we're going to demonstrate, again, allow you to search through an array for a specific value, whether it happens to be a short integer, integer, double integer, or real. And then that last one on the list is the one we talked about on the previous slide, and that is a UDFB that allows us to find a character from an array of characters, okay, which you can just think of as a data list. So that's another one that we're going to be demonstrating for you today. Okay, now, how do we use user-defined function blocks if we're using structured text? Okay, well, let's just talk about the approach we're going to take, and it's the same regardless of language at the beginning. So you always have to start, if you're going to be using a UDFB in your project, you always have to start by importing it into your project. And UDFBs are stored as separate files, okay? So what you do is you go to the Navigator section of Cscape, you go to the Logic Modules entry in your data tree there, or your project tree. You're going to right-click and hit Import Logic Module. And then Cscape will take you to a dialog box where you can navigate to the folder containing the UDFB files. You can import them, the ones that you're wanting to use, into your project one by one. They'll show up under UDF modules further down in the project tree. And then that's step number 1. The next step is you need to effectively create instances of those UDFBs for every case in your logic where you want to add one of those to your logic. So if you're only going to use a particular UDFB once in your project, you only need to create one instance of that UDFB, and you give it a unique name and a type that is the same type as the name of the UDFB. Because once you've imported a UDFB, it shows up under your pull-down list of all the different types. The types pull-down list is where you find, double int, real, int, etc. And also on that list are any structures that you've created or that were pre-created, and also any UDFBs. So again, create an instance of that UDFB for every time you want to use it with a unique name. All right, so that is really the approach you're going to take to get a UDFB into your project, regardless of which language you're using. Okay, now let's talk about the specific inputs and outputs that you would use with the 4 data-find UDFBs. Now remember, those 4 data-find UDFBs are really all the same. They only vary in terms of the type of data list or the type of array that you're searching through, whether it's an array of short integers, double integers, or real values. Okay, so on the input side of things, all of these UDFBs have an enable input, and that needs to be turned on in order for the UDFB to function. And you should turn it on and leave it on until you've got the results you're looking for. The next input is called target value, and that is the specific data value that you're searching for. And again, the type of value that you're searching for is going to vary depending on whether you're looking for a short integer, an integer, a double integer, or a floating point. But the name of that variable is the same regardless of which of those 4 UDFBs you're using. You've got an array of data that you're going to be searching through. So that's the 3rd input on the list there. And again, it's going to vary in its type depending on the type of array it is, whether it's short integer, double integer, or real. And then the last thing you specify is the last index that you want the UDFB to search through. Okay, because it has the capability of searching as far as up to 1,000 elements, 0 to 999, in a particular array. But if you've only got an array of, say, 50 values, there's no sense having it search to 1,000. Just have it search to whatever the last index is in your list. That's also a safeguard to prevent the execution of a program where you could be searching beyond the end of an arrayed variable, which is always a bad thing. So anyway, last index is a double integer value, which represents the last index number for the particular array you're searching through. All right, on the output side, you've got 3 outputs. You've got a done output, which will turn on whenever the UDFB is complete with its operation. You have a output which tells you the index number where it found the data you were looking for. And if it doesn't find the data anywhere in the list, it's going to return a -1. And then it has an error bit that it can turn on if, for whatever reason, you're trying to search through a list greater than 999. So if you set last index to 2000, for instance, it's going to give you an error bit in that scenario. Okay, so those are the inputs and the outputs for those 4 data-find UDFBs. Okay, now let's talk about the specific input and outputs to the find char or find character UDFB. Remember, this is the one we're going to use to search through an array of characters or an array of short integers, unsigned short integers, which is how standard IEC in Cscape handles strings. Okay, so on the input side, again, you've got an enable, works the same as the other, where you need to turn it on and leave it on until you're done with the function block. It's only going to execute, though, on the leading edge, but you should leave it on until you get all the data out of it that you want. You've got an input array, which is an array of short integers, which represents characters, of course. This time, one thing to be aware of is that find character is a UDFB which is 1-based. So you're specifying the last position you want to search, which is 1-based, not the index, not the last index you want to search. And then you've also got a variable called character, or CHAR, which is the ASCII value of the character you're looking for, which again is a short integer. And on the output side, again, you've got an error output, and then you have the result, which is also 1-based for the position of the character where it was found. So if you're looking for a carriage return, which I believe is ASCII 13, either ASCII 10 or ASCII 13, I don't remember. But anyway, if you're looking for a specific character, it will tell you where it found it in a 1-based fashion. So if it found it in the 5th member of the array, it's going to return a 5. So that would be an index of 4 or position number 5. Find character is going to return a 5. Okay, now specifically when you go to code structured text and you want to utilize UDFBs, how is that done? Well, let's talk about the syntax first, and then in the next slide, we'll talk about the specific code that you need to enter to make it all work. Okay, so you effectively need to do a function call, and that is done there on that top line, the line that starts with find character, find underscore CHAR. That is the function call. So you have the name of the UDFB, and then in round brackets with commas in between them, you have the 4 different inputs for that UDFB. And then for the outputs to access those, you use assignment statements. And you have a variable name for whatever the variable is that you're going to be copying the output to, is on the left side of the assignment statement. And then the output name after a dot and after the name of the UDFB is shown on the right-hand side there of the assignment statement. And you do that, you have an assignment statement for each of the outputs that you're going to retrieve. Now, from a specific coding standpoint, let's take a look at this next slide. So in reality, you aren't doing a function call using the name of the UDFB itself. You're using the name of an instance of that UDFB. So if the find character UDFB is what we were using, we would have to first create an instance of the find character UDFB, which I've named on the screen find carriage return or find CR. And then I have within the round brackets separated by commas 4 different input variables, which are going to be used as my inputs, or 4 different variables that are used as the input variables for that particular function. And then I have the 2 assignment statements below that where I'm retrieving the error and the char position outputs into a couple of variables that I have created, error and CR position. And it's very important to remember that UDFB instance names and variable names must be unique. You can't use the same variable names in your UDFB code that you use in your main code. That can cause a problem. Okay, now let's go ahead and take a look at a demonstration of these data-find UDFBs. Okay, so here we are in Cscape. So let's take a look at our example program here. Now, the first thing I had to do in my example is I needed to import in the user-defined function blocks that I'm using for this particular project. And as I described on the slides, you start over here in the navigator, you right-click on Logic Modules, you click on Import Logic Modules, and then you navigate to the specific folder that contains the UDFB files you want to import. And then one by one, you import those, and as you bring them in, they show up here under UDFB modules. Okay, and then once they're there, they can be used. Now, before you can use them, every time you're getting ready to use one, you need to create an instance of that UDFB in your variable list. So down here, you can see I have actually created one instance each for each of these UDFBs that I've imported. Now, I could have multiple instances of any one particular UDFB if I wanted. There's no limitation at all. But every time you create a new instance, it has to be a unique name. Now, in this case, let's look at the first one, for example. I have a variable or an instance of a UDFB that I've called test find short integer. And the data type for this particular variable I've created in my variable window is actually the name of the UDFB. So after I've added a UDFB to my list, it will show up under the type names, where I find integer and dint and any structure names or anything else that have been created. I also find the UDFBs listed here as well, so I can use those as types. Okay, so I have to create an instance of a UDFB before I can call it. All right, so I've done that now. So let's go up here to the top, and this is an example of the coding that we might use to find a specific value of a short integer. That's effectively a signed byte value, to find a short integer from an array of short integers. So here is my function call. Okay, here's my function call, which matches the instance name for the function block that I want to call. All right, inside of round parentheses are my input variables separated by commas. All right, and then in this scenario, I'm actually retrieving 3 outputs from the UDFB using assignment statements and copying those output values, the done, the err, and the value index, over to other variables that I have created in my program variable window as well. Okay, so that's the syntax that I use anytime I'm searching an array of values using one of these UDFBs. And again, it's the same effective syntax for short integer, integer, double integer, and real versions of those UDFBs. Now down here under find character, I also have some coding for that to show you here. Again, I'll go ahead and spread it out so you can see it a little better. My top line here is my function call with the name of the instance that I've created of the type of the UDFB that I've imported. Oh, and this is also handy. If you can get your mouse in the right spot here, it will give you a tooltip that will show you the details on the inputs and outputs for your UDFB function. Very useful if you forget what the data types are and those sorts of things. All right, so that's how you do the function call. And then down here, I'm using assignment statements to retrieve output values, in this case, the err output and the care position output as well. All right, so that's what Cscape coding looks like, calling these specific user-defined function blocks using the structured text language. Next, we're going to take a look at this on the bench. Okay, so let's start with our data search through an array of short integers. Okay, so in the center of the screen there, I've got just really a short snippet, 5 particular elements in an array that could be as large as 1,000 data values long. Okay, and I've got an enable button on the left. When I press that button, it's going to effectively enable this particular function. The target data field there is the data value I'm looking for. Below that is the last index that I'm going to check in my array. So even though I could handle as many, let's say, as 1,000 elements to search from, if my array has a maximum index of 31, indicating there's 32 elements in the array, then I want my end index to be checked to be equal to that last index number. Because if I don't find the value I'm looking for when I get all the way to the end, I don't want to just keep going through a loop. I want to make sure that I finish up and return a value that indicates I did not find what I was looking for. Okay, and then in the center there, I've got, again, a snippet from index 0 through index 4 from top to bottom of some short integer values. And then on the right are my outputs, effectively. The result numerically after I run my UDFB, and my done bit and my error bit if it happens to turn on. All right, so let's execute this and see the result we get. Okay, so you can see we got an index result of 2 on the far right there. That means 0, 1, 2. The middle element is where we found our target, which was 57. Okay, so the first 57 it came across was at index 2. Now, you'll notice there's another 57 at index 4, a couple spots down there, and it didn't return a 4, and that's because these UDFBs always return the first instance of the target data that they're looking for. So we were looking for 57. As soon as we found a 57, we returned that index number. Okay, and the rest of these functions work exactly the same. We'll go through them real quickly. Okay, same looking demonstration here, this time with an integer where we're looking for a value of 745. Again, we find it in the list. This time, let's look for a value that isn't here on the list. Now you'll see that when we execute this, we get a value of -1. All right. So if it doesn't find what it's looking for, you'll get an index result of -1. And there's really no difference if you're looking for a double integer or a real. The function executes the same, gives you your result at the end there under your index result output, and the done light turns on. And of course, when you turn off the enable, the done light goes off and your index result goes back to 0. And then finally, we have the floating point version of the same. This time finding our 1.9 at an index of 3. Remember, from top to bottom, we're looking at index of 0, 1, 2, 3, and 4. Okay, so that is a look on the bench of how our data find user-defined function blocks worked. Okay, with that bench demo, that wraps up the material I wanted to share with you today. This here is a reminder that we're here every Tuesday at 2 o'clock, whether we're fully live like we were last week, or whether we're pre-recorded like we are this week. But we've always got folks standing by to answer your questions, whether you're watching live, and we respond quickly to the comments you make when you're watching on replay in the comment section. Okay, so our training schedule, I want to remind you, don't wait too long to sign up for training because the spots typically do fill up very quickly. We still have open spots for all of our training courses, and they're listed here on the screen. Of course, to sign up for those courses, you need to go to our website at www.hornerautomation.com. And if you want to go directly to the training site, you can add a /OCS-training to the end of that. Okay, to interact with us online or on social media, there's lots of ways to get in touch with us at our website, of course, on our YouTube channel, and also on LinkedIn, where we are quite active. Okay, so we're still working up the specific live streams for February. Now, I can tell you we will be likely covering another structured text topic next week. We're probably going to be talking about some of the same type of string operations and maybe some data find operations and those sorts of things, but this time with enhanced IEC. Cscape offers an enhanced IEC mode that has some additional instructions. We're going to go through those next week, more than likely. Okay, if you haven't subscribed to our channel yet, don't hesitate to do so. It doesn't cost anything. And if you choose notifications when you subscribe, you'll be notified every time we go live or every time we post a new video. Okay, so until next week, until we talk again, probably about structured text, let's all get out there and do us some good.